Hello everyone, to all the Form 4 students. Today is actually the day for us to discuss the exercise. Okay, we are going to discuss the self-practice 1.9. Please do this exercise in your book A. Alright, so we are going to discuss one by one so that you have a clearer picture of the exercise that you do. Okay, the first one is determine whether each of the following function has an inverse function. So now we need to study the object here, object in the domain, and the image is in the codomain. This is codomain, right? Okay, so every element, example 1, 2, 3, 6 are objects, and each object has actually mapped to one image. 1 go to 8. Follow the function is 2 plus 6 over x. So if it is 1, the image will be 2 plus 6 over 1, which is 8. So if it's 6, will be 2 plus, if the object is 6, then it will be 2 plus 6 over 6, which is 3. Right? So it seems like every object has only one image, right? So it's a one-to-one relation. So this function in fact has an inverse. So how to explain in detail? Let's explain in detail. The function maps one element, 1, 2, 3, 6 are elements in a domain, this is so-called domain, to only one element, 3, 4, 5, 8 in a codomain, this is so-called codomain. So this is function. And the inverse function, okay, the inverse function only maps each element in the codomain from codomain, okay, arrow reverse, to only one element in the domain. This is the domain, right? This is the codomain. Again, this is the domain, right? So for inverse function, the image now become the object, right? And it actually reverse the arrow. So therefore, this function has an inverse. Alright, so that's how you explain your answer. So if the question asking to state the reason or explain the answer, so this is how you answer, right? Okay, so we have discussed one question. So now we go to another question for B. So again, we want to determine the function has an inverse or not. So we study negative 4 image is 13, alright, and then 3 image 6, and 4 is 13. That means we are having many to one, okay, many to one relation. So if we inverse back, it seems like we are having one to many for the inverse, right? So the function does not have an inverse function, right? So how to explain your answer? Let's see how. So the function maps one element in the domain to only one element in the codomain, but there are elements in the codomain that map the two elements in the domain, which is which one? Which is 13, right? This 13, it has two images when come to inverse, right? So then the function does not have inverse function because it become one to many when reverse back. Okay, so this is not having inverse function. Alright, so let's go to number C. Now for this question, you are given the function which is in modulus, right? It's in modulus. So for modulus, actually we have two lines beside, right? So when you substitute any value into the modulus function, let's say you substitute negative 2, it will produce negative 2 minus 2, which is modulus 4, so you'll get 4. So all the value will be positive, right? So is this function has inverse? So when the horizontal line test, so we need to use a test. Let's draw the horizontal line. So we have two intersection points. The horizontal line cut 2 points on the graph. This shows that this function is not one-to-one function. It is not one-to-one function. Right? It is not one-to-one function. So when it is not one-to-one function, the function does not have an inverse function. Okay, so for question that involve modulus, okay, we always have the V shape, all right, with the vertex here. Okay, so I'm going to show you the vertex here, and it must be V shape. So when we conduct the horizontal line test, we have two intersection points. So hence the function does not have inverse function. So for function like this, which is actually if you draw the arrow diagram, the 1 will maps to 2, and then the 4 will maps to 5, and 5 will maps to 8, and 9 will maps to 9. So this is a one-to-one function. Therefore, the function has an inverse function. Okay, it has inverse function. And how about this one? Let's draw out and see. Okay, we just sketch out. Negative 3 maps to 2, negative 1 maps to 1, and 2 map to 4, and 5 map to 4. Okay, 5 and 2 are sharing same image, right? And we have 9 maps to 5. So it seems like we have many to one relation. So the function is a many to one relation. So its inverse would be one to many, right? So if you inverse, okay, let me show you how to do inverse. This is the object. Now if you inverse, the arrow will be reversed, and these two are the images. Therefore, it's become one to many function. So hence, therefore, the function does not have inverse function. Does not have inverse function. Right? Understand? So in order to determine whether the function has inverse of function, first of all, we must make sure the function is one-to-one relation. So for question like this, whereby you have the function fx equal to 4 minus x squared, so if you sketch a graph, basically when you sketch a graph, you have to, let's say, you can say that y equal to fx, right? Then you let the x 0, your y is 4, so you have 1.04, and then you let the y 0, and you find the x-intercept. So that means 4 minus x squared 0, so x you will have plus minus 2. So with these 3 points, and it's a negative, a is coefficient of x squared is negative 1, so you will have the n shape, right? With the x-intercept here, 2 and negative 2, and the y-intercept at 0, 4. Okay, basically you must sketch a graph first, right? So the graph, okay, sketch it. Now we want to determine whether this graph actually has inverse function or not. So we can actually conduct the vertical line test. Okay, let's draw the vertical line. We can conduct the horizontal line test. Okay, so for you to determine whether the function or the graph is having inverse or not, you can draw the horizontal line test. Okay, so this one actually got two intersection point. If you draw horizontal line test, when horizontal line test is done, the horizontal line cuts 2 points on the graph. This shows that the function is not one-to-one function, and it does not have inverse function because it is not one-to-one function. Therefore, the function does not has inverse function. All right, so please always conduct the horizontal line test when you see the graph. Okay, so for this one, how about this one? So okay, just now the one maybe I let you copy first. When the horizontal line test is done, the horizontal line cut 2 points on the graph. This shows that this function is not one-to-one function and does not have inverse function, right? So for this one, you have the function whereby is given like this, whereby x more than 2. So when you sketch, you just sketch the part whereby x is more than 2 or the domain of the x. So you're having the line like this when you sketch. So if you draw the horizontal line, you can draw as many as you like, and you notice that when horizontal line test is done, the horizontal line cut 1 point on the graph. This shows that the function is one-to-one function and has inverse. Okay, it has inverse because it is a one-to-one function. Alright, so for next question, question number 2. Are the following function f, g the inverse function, okay, of each other? Verify the truth by applying the relation f gx equal to g f x equal to x. So now we need to substitute f, okay, into g and g into f. So let's substitute g into f. So we will have to refer to fx, right? So if you are having f something, you have 3 something minus 2. So now you need to substitute gx inside. So the gx is x plus 2 over 3. So if you cancel out, you will actually simplify and you got the x. So it means that you are having the x, which is object. Now let's try gfx. Okay, let's try gfx. Okay, for gfx, let me show you how to find gfx. We will sub the f into g, so we copy the function g first. When we see x, we leave it blank, and then we will substitute the f into the g. Is 3x minus 2, right? So we have 3x minus 2 plus 2 will be cancelled out due by 3. So we have 3x over 3, which is x, right? So finally, we can say that we found out the fgx, we find out the gfx, we actually get the x for both, and the function of f and g are inverse to each other because they produce the x, which is the object. So that is how you verify the truth by applying the relation fgx and gfx equal to x. Alright, so let's do this one. So you're having fx and gx. So let's find fgx. Okay, so for fgx, we will substitute. Okay, we'll refer to this one. We will substitute gx into here when we see x, right? So it's a bit complicated. So when you do this one, you need to be very careful. Okay, how to simplify this is you have to make it fraction, and then you times x minus 2, and then you will actually having the denominator like this, minus 3x plus 6, right, over x minus 2, and then you have to, you have this, it means divide. So you have to divide by this, and when you divide, okay, this is actually 6, right? So this thing is actually 6 over x minus 2. So when you divide, you want to simplify, you must actually inverse, right? So this one go up, 6 go down. Then only you cancel out the 6 and you cancel out x minus 2, then you will get x, right? Understand? Okay, so for this one is you sub the f into g. So we will copy down the g. We'll copy down the g, the function g something 3 something over something minus 2. The something that you need to put in is a fx, this one. So you put the fx here. So this is a fx and this is a fx. Okay, fx. And then when you simplify, you need to be very careful. This one is 3 times 2, 6x, okay? And the denominator, you need to make sure it is simplified like this. You're having the same denominator, right? So if the denominator is the same, let's simplify like this. It will be 2x minus 2x. This one multiply in negative 2 plus times negative 3 plus 6 over x minus 3, right? So you have 6x here, x minus 3. So when you inverse, the x minus 3 will go up. And you cancel, you get x. So then the answer that you get is actually, so when you try to simplify, okay, when you try to simplify, so this one cancel out, so it becomes 6 over x minus 3, but it's dy. So when you multiply, you have to inverse, then you cancel out 6, you will get the answer x. So thus the function f and g are inverse to each other because they can produce x. Alright, understand? Okay, I hope you understand. So you can try to explore as many as you can like this. For C, okay, for C, we are finding the fgx. That means okay, for C, we actually find the fgx. So we start with the fx, we sub the g. So we'll substitute the g into the f. So we will copy down the f. So the moment we see x, we sub with the gx. So after that, when you simplify, you need to write this one as dy. And then this one you need to multiply by x up and down. So finally you will have 3x minus 2 minus 3x, right, over x. Then you simplify, you will get x over, this is 2, negative 2 over x. So when you multiply, you have to reverse, so it becomes negative x. And this one, if you find the gfx, meaning that you sub the g into the f, right? So let's see how to sub the g into the f. So this is your g. Here you sub the f. You sub the f. Wow, this is very complicated. So you will do like that. This is f and this is f. So we will actually make the denominator the same by multiply up and down with x minus 3. So it become here, if I simplify, I will get the 3, 2 is 6 minus 2x, and then negative 2 and negative 3 will be plus 6. So you're getting this over x minus 3 dy by the fraction dy. When you see this one, you convert to dy. Then after that, you simplify, it will be 6, 6 will be 12 minus 2x, and this one you need to inverse. Okay, this x minus 3 go up and 2 go down. Alright, then only you can simplify. Okay, when you simplify, you can just cut the common factor, and this one is actually 6 minus x over 2. So you cancel out the 2, you get 6 minus x. So the function of f and g are not inverse to each other because we are not getting the x, which is the object. Okay, try this on your own. Please do all the exercise that I discussed in the exercise book. So this one we try to find fgx, meaning that we are going to sub the g into the f. So 2 plus 5, the bracket is gx. You substitute inside. This is gx, right? So after you simplify, this is times 2 over 2, right? So you get 4 plus 5x, negative 25 over 2. And then you will get the answer 5x minus 21 over 2, right? Okay, finally, let's find g of x, meaning that I'm going to sub the f inside, and here I'm going to sub the 2 plus 5x. So this is quite simple. Minus 5 over 2, and you got 5x minus 3 over 2, which are not the same. So the function f and g are not inverse of each other because they are not producing the object x.